Hi, I'm Sophia, and today I'm going to give you an introduction to the world of science behind meteorites. I think it's safe to say that everyone's familiar with meteorites. They're featured in countless movies, TV shows, and books as magical rocks from outer space, bearing dangerous and mysterious secrets. But anyone who's taken a high school science course knows that that probably isn't really the case. So, what actually makes meteorites so special? To even begin to understand that question, we first have to understand the basics of meteorites. There are two main categories of meteorites, achondrites and chondrites. Achondrites are homogeneous meteorites that form early in the solar system in bodies large enough to melt down and differentiate, with heavy metals sinking to the core and lighter elements rising to the surface, a lot like Earth. On the other hand, chondrites are heterogeneous meteorites that contain small nodules called chondrules. Chondrules harden from small droplets of molten rock formed at the very beginning of the solar system and served as the building blocks of every single object in our solar system. How cool is that? By compositionally analyzing chondrules, we can gain new insights into the history of our solar system. But how exactly can we analyze these chondrules? Well, I'm glad you asked. I work in a lab researching meteorite petrology at the University of Kentucky. In order to analyze a meteorite, I use what's called an SEM, or a scanning electron microscope. This microscope allows me to view the chondrule at a nanoscopic level. Then I can use energy dispersive X-ray spectroscopy, or EDX, to analyze the composition of any point on the surface of a sample. EDX sounds really fancy, but it's honestly pretty simple. Basically, I shoot a point with a high energy electron beam that knocks valence electrons out of their shells and replaces them. Since there's a discrepancy between the electron energy levels and that energy has to go somewhere, an X-ray is released, and this X-ray can be measured to determine what atom the interaction took place in. By measuring the amount of different X-ray wavelengths, the technology in my lab creates a spectrograph, like the one seen here. These spectrographs show me the amount of each element present. I can compare the ratios of elements to determine what minerals I'm looking at and help gain a better understanding of what materials made up our early solar system. Thank you. Here are my references, and I hope you learned something.